Good morning, friends. So today we are going to discuss about the inventory control. In the inventory control management, we are solving the problems on Eoq models. So first, before going to the problems, so we should know the definitions of the inventory control and objectives of the inventory control. So the inventory control basically deals with the two problems. So when we are going to order and how much quantity we are going to place order. So when we should order, so that is about order level, and how much quantity, how much should be order. So the Eoq deals, inventory control deals with the how many times we are going to place the order. So inventory control is a planning approach determining what to order, when to order, how much to order, and how much to stock. So the costs associated with the buying and storage are optimal without interrupting the production and sales. So the main things, so here is when we are going to order and how much we are going to order, how many times we are placing the order, how much quantity we are placing the order. So buying and storage are optimal without interrupting the production and sales. So when we place the order and how many times we are placing the order. The objectives of the inventory is, so it will be continuing the supply of the material, avoid overstocking or any understocking. So we need to maintain the reorder level point. So every time, so the reorder level point is there, so stock will be there. So every time we are going to reorder that. So in continuous flow supply of the material in order to avoid of the production interruption. So here we are giving the continuous supply of material, avoid over and understocking, maintain investment as optimum level, keep the material cost under control. So at the end of the point, minimum losses of deterioration, free life, wastages. So if any wastage is there, so we minimize the losses of deterioration, minimize the wastage, avoid under and overstocking. So these are the objective of the inventory management. So this is about inventory order cycle. We are solving the problems on Eoq, economic order quantity models. So the terminology we are using in the economic order quantity is CO, cost for placing order. CC is the carrying cost, annual per unit carrying cost. Ordering cost CO, CC is the carrying cost, where D is the annual demand. Q equal to ordered quantity. Q equal to order quantity. So the annual ordering cost is equal to ordering cost into demand by economical order quantity. Then annual carrying cost multiply with the average of a ordered quantity. Then the total minimum inventory cost that equal to ordering cost into annual demand by economic order quantity plus carrying cost and the average of ordered quantity. So we will solve the problems, Eoq problems based on the Eoq. So the Eoq means how many times we are placing the order, how many times we are going to placing the order, and how much quantity we are going to place the order, when we are going to place the order, like that. So we need to solve the problems on Eoq models. Now we'll solve the problems based on Eoq model. So this is the carrying cost. The numbers will be in the dollar form. The carrying cost that is equal to 0.75 per yard. Ordering cost that is $150, and annual demand that is about 10,000 yards. So now we'll solve the Q optimum, economical order quantity. The formula for economical order quantity under root of 2 ordering cost into annual demand by carrying cost 2 into ordering cost into annual demand by carrying cost. So we'll substitute the values. We'll find the economical order quantity. The Q optimum equal to 2. The ordering cost is 150 and annual demand is 10,000 and carrying cost is 0.75. So finally we'll get order quantity, economical order quantity. So that is about 2,000 yards. So every time we are placing the order in, the quantity will be 2,000. So the annual demand is 10,000. Then how many times we are placing the order? That is about orders per year. Annual demand equal to 10,000. Q optimum equal to 2,000. So every time we are placing the order, is 2,000. So number of orders per year, that equal to 10,000 by 2000, then 5 orders per year, 5 orders per year. So this is about number of orders per year. So now we'll solve the total inventory minimum cost. Total inventory minimum cost. So that formula equal to ordering cost into annual demand by quantity plus carrying cost, the average of ordering quantity. Average of ordering quantity. So we'll substitute the values in the total inventory minimum cost. So the ordering cost equal to 150, annual demand is 10,000. Q, just now we calculated the Q, so that is about economical order quantity, that equal to 2000 plus carrying cost is 0.75 and annual demand carrying cost is 0.75 and order cost is 2. That average of, we have taken average of this economical order quantity, then the total inventory minimum cost equal to 1500. So this is about orders per year. So this is about orders per year. Now we are going to calculate order cycle per time. Now we are going to calculate order cycle per time. So this is about orders per year. So every time we are placing the order, that is a 200 quantity, number of times, how many times we are placing the order, that equal to annual demand by quantity, then 5 times we are going to order, 5 times we are going to place the order. Order cycle time is, so 365 days, our annual demand is 10,000 yards. So our order cycle time, days by Q up to, so 360 by 365 5. So we have orders per year, every time we are placing the order in 5 times, so the 365 by 5. So the order cycle time is 73 days. The order cycle time is 73 days. So this is about problem 1. So now we'll solve the problem 2 and 3 also. We are solving the problem 2. This problem also are related to the economic order quantity. So in the problematic manner. So the ABC corporation has got a demand of particular part as 10,000 units per year. The cost per unit is 2 rupees. That is about ordering cost, and cost 36 to place an order and to process the delivery. The inventory carrying cost is estimated at 9% of cost per unit. So what we are going to find? Determine the economic order quantity EOQ, optimum number of orders to be placed per annum. The third one is minimum total cost of inventory per annum. Minimum total cost of inventory per annum. So here also annual demand is 10,000. The cost per unit is 2 rupees. It costs 36 to place an order. The inventory carrying cost is estimated 9% of cost per unit. So the cost per unit is 2 rupees and the carrying cost is estimated 9% of cost per unit. So 9% of, so that is about inventory carrying cost is 0.09 into 2 rupees, that is 0.18 per unit. The carrying cost is 0.18 per unit. So in the given data, annual demand for parts D equal to 10,000 units per annum. Ordering cost is 36 to place an order. Ordering cost is 36 plus 36 per order. The cost per unit is 2 rupees and inventory carrying cost is 9%. The inventory carrying cost is estimated 9% of cost per unit. 9% of the inventory carrying cost is 9% of cost per unit. So that is about 0.09 into 2 rupees, that is 0.18 per unit, that is about inventory carrying cost. So now just now we are going to calculate the economical order quantity. If the economical order quantity EOQ is known, then easily we need to find the number of times we are going to order. Then we need to calculate the total inventory minimum cost. total inventory minimum cost. So the economic order quantity EOQ. So the economic order quantity EOQ optimum equal to under root of 2 into ordering cost into annual demand by carrying cost. 2 into ordering cost into annual demand by carrying cost. So we know all the values. The ordering cost is 36 rupees and annual demand is 10,000. The carrying cost is 2 into 0.09. Then economical order quantity is 2000 units. So the EOQ economic order quantity is 200 units. So now we are going to calculate optimum number of orders. Just now we calculated the Q value. So under root of 2 into ordering cost into annual demand by carrying cost. So the EOQ is 2000. So we know the annual demand and we know the EOQ, that is about 2000. So the optimum number of orders in the previous problem, the same as the previous problem. The optimum number of orders is annual demand is 2000, Q optimum is 2000. So 5 times we are going to place the order. Optimum number of order is 5. Then we are going to find the minimum total cost of inventory per annum. T minimum total cost of inventory per annum. Minimum total cost. So the minimum total cost formula is ordering cost annual demand by economic order quantity plus carrying cost average of the order quantity. That equal to Q by 2. Annual demand, ordering cost into annual demand by the economical order quantity plus carrying cost average of EOQ, average of the order quantity, that equal to Q by 2. So ordering cost is 36, annual demand into 10,000 by EOQ is 2000, that is about. Then carrying cost equal to 2 into 0.09, the quantity is 2000 by 2, average we have taken, so that equal to 180 plus 180, that is about 360. So this is the minimum total cost of inventory per annum. So the minimum total cost of inventory per annum is 360 per annum. So this is about economical order quantity. If the annual demand is given, carrying cost is given, ordering cost is given, so simply we are solving the economic order quantity. So that the formula is under root of ordering cost into 2 into ordering cost into annual demand by carrying cost. 2 into ordering cost annual demand by carrying cost. If you know the ordering cost and annual demand and carrying cost, simply will follow the EOQ models. So the EOQ economic order quantity. So the EOQ means how many times we are placing the order, when we are going to placing the order, how much quantity we are going to placing the order, how much time we are placing the order, how many times we are placing the order, how much quantity we are going to place in the order. So this is about EOQ. So now we will solve the problem 3. So if scientific EOQ problem model is not followed, how much the loss will be. So we are going to see. So we are placing the order in the randomly. So this is about problem 3. If not scientific EOQ model is not followed, how much of the loss of the organization. So we are solving the problem 3. So XYZ corporation currently practicing the following system for the procurement of an item. So number of orders placed in a year, that equal to 8. Ordering cost 750 per order. Each time order quantity, that equal to 250. Carrying cost 40% of cost per unit. So the cost per unit is 40 rupees. 40% of the cost per unit, that is about 0.4 into 40, that may be 16. So what we are going to find is comment on ordering policy of the company and estimate the loss to the company in not practicing the scientific inventory policy. So we need to estimate the loss to the company if EOQ model is not following. So we are following the randomly, we are ordering the randomly, then how much loss will be, how much going to the loss of how much of the loss of the organization we are going to see. So here number of orders placed that is equal to 8, ordering cost is 750. Each time the order will be the so this is the problem we are going to calculate. If scientific Eoq model is not followed, so how much of the loss of the organization we are going to see. So this is about problem. So this is about given data. So the annual demand is 2000. So 250 into 8, 2000, and order cost is 750 for order. So the inventory carrying cost, so the carrying cost is 40 rupees. The 40% carrying cost is 40% of the cost per unit. Cost per unit is 40 rupees, and 0.4 40%, that 0.4 into 40, that equal to 16 per unit. So that is about carrying cost. So if you know the ordering annual demand, ordering cost and carrying cost, simply we know we need to calculate the Eoq, economic order quantity. So that Eoq equal to, so our Eoq equal to under root of 2 into ordering cost into annual demand by carrying cost. So this is about Eoq, 2 into ordering cost into annual demand by carrying cost. Then simply we need to substitute all the values in the equation. We need to calculate the economic order quantity. So the economic order quantity Eoq equal to 2 into ordering cost into annual demand by carrying cost. So the Eoq is 433 units. 433 units. So now we calculate the present system Eoq. So they are following. Before going to that, we need to calculate the total inventory cost of total inventory cost also, total minimum total inventory cost, minimum total cost of inventory per annum, that equal to ordering cost into annual demand by Q by carrying cost, average of order quantity. So that equal to 6,928. So this is the minimum total cost of inventory per annum. So this is about the minimum total cost of inventory per annum. So if you follow the economic order quantity, so the minimum total cost of inventory per annum equal to 6,928 per annum. So now we'll solve the present Eoq if scientific Eoq model is not followed. So what is the minimum total cost of inventory? So the present system. So the inventory, the total inventory cost under present system is annual ordering cost. Annual ordering cost is so every time we are placing the 8 times we are going to place the order. So order is ordering cost in each time the ordering cost is 750. So that 6,000 plus annual inventory carrying cost. So annual inventory carrying cost so this is the problem. So number of order placed in 8 and ordering cost is 8. Each time order quantity is 250. So present following the total inventory cost under present system is annual ordering cost. So 8 times we are going to place the order. So every time the ordering cost is 750. So that is about 6,000. Then annual inventory carrying cost 250 by 2 into 16. So that is about 2,000. So the total inventory cost, that is about 8,000. The total inventory cost per unit system, present system is 8,000. So if the scientific Eoq model is not followed, how much of the loss? So loss of the company, if not operating scientific inventory policy. So 8,000 minus the total inventory minimum cost is 6,900. So if follow the inventory total Eoq models, if follow the Eoq model, the minimum total cost of inventory is 6,928. So if not follow the scientific Eoq model, the loss will be 1,071. the loss of the organization, that will be 10,000 1071 rupees. So that's why we need to follow the EOQ models. EOQ means economic order quantity, how much time we are going to place in the order, how much quantity we are going to place the order, when we are going to place the order, right? When we are going to place order, how many times we are placing the order. So that is very important. So if not following the scientific techniques, the loss of the organization will be like this. So I hope you are understanding the concept of the EOQ models and the problem solving of the EOQ models. Thank you.